Hello and welcome to another JavaScript project. My name is Mark Lassoff from Framework Television. I'm really glad you're here. If you like these projects, don't forget to like this video and subscribe. Let's first take a look at what this particular project looks like when done. This is a weather conditions application. So in order to run this, we're going to need to run our HTTP server. And if you have a Mac, this comes out of the box, the simple HTTP server. I always forget the little flag that you need here, -M. And then the port we want to run this on, we'll run it on port 8000. That'll start our server. There's a version of this for Windows 2 that you can download. And you can see we're serving at port 8000. So let's go ahead and localhost 8000. And here you can see our Weather Wizard app. All we do is we type in a city's name, we click Get Weather, and then we can see the current conditions for that city. So right now it's 49 degrees Fahrenheit in New York, humidity is 87%, pressure is 1006 millibars, and the wind is 130 degrees at almost 9 miles per hour with some mist. Try another city. Let's try San Diego. Bet it's a little warmer there. And it is 67 degrees, 72% humidity, clouds, you get the idea. So obviously we're using a couple of tools that already exist for this application. First, we're using the Onsen framework. Now this is a framework that lets you easily design mobile applications using HTML5, CSS, and JavaScript. It provides all the components, like the buttons, the inputs, lists, etc. We're also using the Open Weather Map API. That's a partially free API. The part we're using is free, where we're getting the weather information. Let's take a quick look at those. So I've got those open in my browser. And first of all, here's Onsen. And this is at onsen.io. And this is a great way to skin your project. If we take a look at the API components here, there's a lot of CSS components that can be used, like switches, range sliders, notification icons, navigation bars. And notice as I thumb through these how much these look like the components on either an iOS device or an Android device. And that, of course, is by design. We want the components to look like they're actually from the device itself, so an HTML5 application feels native. The user doesn't notice a big difference between this app and other apps on the device. That's exactly why we use Onsen. Now the weather API that we're using here, openweathermap.org, first thing you should know is you do need to get an account for this. So I'm already signed in, and the account is going to give you access to, as part of the API, your API password. That password is really important because you're going to need that in order to do anything with the API itself. So on the API here, we're using the current weather data API. If I click the API documentation, I can see all the documentation that's part of this API. It shows me what I can send the API. For example, I can send it a city name, like we're doing, a city ID, geographic coordinates, latitude and longitude, a zip code, and it's going to return, by default, JSON that looks a little bit like this. JSON is JavaScript object notation. It's a way of passing information back and forth between systems without regards to the type of system that you're sending, because it's all text. Okay, so let's start taking a look at our app itself. I've got the code over here on the right, and the code is in 3 separate files. We've got our index.html, which of course contains the HTML, the stuff that gives us the scaffolding for our application. Our CSS, Now the reason there's not much CSS here is I mostly use the CSS from Onsen. I used their styling for the most part. There was a couple of small modifications I made, so they're in my external CSS file. And then the heart of our application, weather.js, this is the JavaScript that does all the work. You'd be surprised to learn it's less than 50 lines. So this again is a pretty simple app. But there are some layers of complexity here that'll make this valuable for you to learn from. So we're going to go line by line, starting with the HTML. So we'll move to index.html. And here you can see we've got our scaffolding for the app itself, for all of the components on the left-hand side that you see on the app. So line 1 is our doc type definition, simply indicating that we're coding in HTML. And in line 2 is part of our basic document structure, our opening HTML tag indicating that the language is English. And the direction is left to right, unlike some Middle Eastern languages which are right to left. These two attributes aren't really necessary, but the template I use includes them, so I leave them there. The head section of our document includes first a meta tag indicating we're using the character set UTF-8. It's also from the template that I use. The title of our document is Weather Application. And then we have the link to a couple of style sheets, just neatening things up as we go here. The first two style sheets are part of Onsen. I got that directly from the Onsen documentation, so this is downloading the Onsen style sheets for their UI. And you can see that styling, the button, this toolbar here, etc. The third style sheet is the Weather CSS style sheet that I showed you. That's this style sheet right here, where I'm simply adding some padding in strategic places in the document. And then finally, we're adding our JavaScript. This is the Onsen JavaScript. And then I have a file called key.js. The key.js file is where I'm hiding my key for the Open Weather Map API. You don't want your key to get public. Now, it's no big deal if it did. I could just switch out my actual key, but I don't want to be bothered to do that, so I'm hiding it. It's in a file called key.js, and that file simply contains the key in a variable called key. You'll see how that's used in a minute. All right, and that's all I'm loading in the head. So again, in the head, we have our meta tag for the character set, the title, our links to the Onsen style sheet, our link to my style sheet, a script from Onsen for the JavaScript component, and then my key. Now, you may be wondering why I'm actually loading the Onsen library externally. And at this point, I'm simply doing it for convenience. I could download the entire Onsen library if I desired to do so. But for the purpose of this video, because it's already going to get kind of long, I just went ahead and used the CDN, the Content Delivery Network. OK, so now into the body. And from Onsen, I'm using these Onsen components which starts with ONS dash. What Onsen is actually doing is extending HTML and adding tags that you can use for the various components, like the toolbar. So ONS toolbar is providing that toolbar that you see at the top of the document. In the code, it's on lines 14, 15, and 16, and that's what's providing the toolbar that says Weather Wizard. So the Weather Wizard text is coming from right here, but the toolbar design, that's coming from right here. Again, designed to look like a standard mobile app. I then have a section, and in that section, I've got a text input. That's where we input the city name. So that text input is ONS-input, because I'm using the one from Onsen. ID is TXT city. We need an ID so I can later access what the user types in there through the JavaScript. The modifier modifies our ONS components, our Onsen components. I'm modifying it as underbar to give it this look with just the underline where the user types. And then we have a placeholder. The placeholder is what's there by default when the application loads before the user changes it. I'm using that in lieu of a label. That's becoming very common right now. a class from my style sheet called clearance, and that just adds a little clearance at the bottom here so the button's not right on top of it. So that's our ONS input. One thing I discovered when using ONS components, make sure you formally close them. Don't just do a slash at the end of the opening tag. Don't do a shortcut close. Seems to cause problems. Do a formal open tag and close tag when you're using the onSend components. Then we use the onSend button. That's in line 20. I use the modifier large to give us that big, large button that goes all the way across. I like that button because it's easy to touch with my fat fingers on a mobile device. And I ID'd that button BTN Weather. Right? We're going to need to use that button in the JavaScript because it's when that button is clicked that the action happens, right? Click. So we've got to be able to detect that click. On the button itself, the text get weather is written. And that closes the form section here. And I created a second section for the result on line 22. So where you're seeing the actual current conditions, that's going right there where my cursor is flashing, right there in line 22. And then we have our script, weather.js. I wanted to load all of the HTML components first and then load the script. This way, when the script loads, the components are already stored in the browser DOM, and I can make references to them. So that's my final script loading on line 24. All right, so now let's take a look at weather.js. So in the first section, I'm going to make references to the actual HTML objects. So remember, when you see an assignment operator, like you do on lines 1, 2, and 3, which you might call the equal sign, but formally in programming is known as the assignment operator, it's the right side of the assignment operator that's evaluated first. So document get element by ID BTN weather. Well, you'll remember from the HTML, BTN weather, there's the ID, is the large button. So we're getting that, and in JavaScript, we're referring to that button as BTN weather. We're also getting TXT city, document get element by ID TXT city. That's the line where the user types the city for which they want to get the weather conditions. Guess we didn't have Orono, Maine. Let's try Freeport. That's probably Freeport, Bahamas it's getting there, 82 degrees. OK, so TXT city is the city. Result out is this area in the bottom where our result output is. So document get element by ID result is getting that result area, right? Here, if you look, ID result. So we're getting this whole section, and we're storing it in a reference in JavaScript called result out. So now we want to react when the button's clicked. So button weather, that's our big button, on click will run this function. So every time this button is clicked, the function that starts on line 5 is run. So first thing we're going to do is we're going to get from this line the value. That's what the user typed in. So that's going to be whatever the user typed in. That's going to be the city name. We're going to store that in a constant called city. So I have Athens right now. The value is Athens. That's stored in city. We're then going to make the URL. So this URL comes from the documentation for the Open Weather Map API. Notice it's api.openweathermap.org. It's real important that when you use any type of API that you read the documentation carefully. Almost everything you need to run the API is in the documentation, but it's easy to miss if you skim. So then, in order to make a query for the city, it's weather, and then Q equals, and this is inserting the variable city using string interpolation. So city has the word Athens. This $ in the curly brackets inserts the value of city, or the word Athens, or whatever the user typed right there. So we're replacing it. ampersand app ID equals, and this is going to be your private key, which I'm storing in that file key.js. So there's a variable that was defined that has the key in it, and that's being assigned right here. I should note, just storing your key in an external file does not make it secure. Someone can still look at that file and use that key. So you've got to be somewhat guarded about your keys to various APIs that you may be using. All right, so this creates a larger URL. Let's do something right here. Let's go ahead and log out that URL to the console. So we're actually going to see the URL right here because I want to show you something. So let's go ahead and load up our console, going to More Tools and Developer Tools, making sure the console is loaded. And let's refresh. And let's use New York. And there you can see right there is the URL. Let's see if we can copy that. Can we copy that? Let's see. Looks like we're going to have to kind of grab the whole thing here. So there's our URL. I'm going to copy that, and let's grab a browser window. And I'm just going to put that URL in the browser window. And now you can see here, this is what's coming back directly from the server based on our request. It's giving us a latitude and longitude, a weather node here, main, mist, description, etc. So this is the text version of what's coming back. This is essentially the JSON text. But we're going to convert that into an actual JSON object, which is going to be easier to deal with in a minute. So we'll go ahead and output that as well. All right, so there's the URL. That URL is contacted with the fetch command. So we're fetching the URL, we're talking to the API, we're sending our key in the city that we want. And then when there is a response, we're turning that response into JSON. So the response, this is what comes back from the actual API. You saw that. We're turning it into JSON, and then we're going to go ahead and put the JSON in a variable called data. We're going to send that data to a function called format response, and we'll assign whatever comes back to output. But let's go ahead and take a look at the actual data before we send it for formatting. So let's console log the data this time. We're going to save. Let's refresh. New York. And here you can see now this becomes a JSON object, and you can see everything that was returned from the actual weather API. Here in the main section, the humidity is 87, pressure 1006. That's pretty small. Let's see if I can make that a little bigger. Now you can see it. A temperature of 282.3. The temperature is in kelvins, so we're going to have to convert that to Fahrenheit degrees. It's not really 282 degrees, at least not in our scale. So you can see all the information here. There's another weather node here that's saying it's misty. So there's a lot of information here, not all of which we're going to use. Here's the information about the wind. So this essentially is the JSON object that comes back that we'll have to parse. So that object is stored in the variable data. Data is sent to format response. So here's format response. That takes that JSON, and we start a variable called conditions, which needs a semicolon at the end of that line. So we create a variable called conditions. We assign it a blank string. And then we take a look. If data.weather.length is greater than 1. Let me show you what's going on here. See this term mist? That comes from inside the JSON data.weather. Let's take a look. Again, I'm going to open our developer tools. Here's our weather object. So data, this whole thing is called data dot weather. There's weather. So in here, this is an array and it only contains one member, description mist. But sometimes the weather might contain more than one condition. It could be mist and something else. So this one is haze that came back from Hartford. So here you can see weather, haze. So we only get one back from Hartford. Well, let's try one more. Just clouds. But sometimes we can get more than one back. So we've got to deal with that condition here in weather. This time we only have one node, scattered clouds, right? Or main description clouds. So here we're determining how many of those nodes did we get back, and we're looping through them. So if we got only one back, then we're going to loop through, and we're simply going to say conditions plus equals data dot weather, and first time through it's 0 dot main. So I is 0 as we go through the loop, so weather 0 main gives us clouds, and you can see the result down here. If there was more than one, we'd also have a one node and we'd continue to loop. Now this next line simply adds the word and between weather conditions until we get to the last condition. So if it's clouds and mist, you'd see clouds and added right there, mist. So this is a fairly complex piece of code for the rare times we have more than one condition. I can't seem to find a city that has more than one condition right now. Let's try one more. Ah, there we go, we found one. Miami has rain and thunderstorm and mist. So if we look at the object that came back from Miami, 0, 1, 2. So this loop is going to loop through 0, 1, and 2. From 0, it's going to get rain, displayed right there. Then it's going to go through 1 in the loop, and we're going to get thunderstorm right there. And then it's going to go through 2 in the loop before the loop ends, and we're going to get mist. Now we're going to check, and basically what this does is it checks, are we on the last weather entry? If we aren't, right, if we're not there, that's a not symbol, data.weather.length, so then we're going to add an and. So that's why we get rain and thunderstorm and mist, but it doesn't say rain and thunderstorm and mist and. We're only adding the and if we're not in the last weather item. So it's a fairly complex little piece of code just to add this and when it's warranted. Now, by the way, we only run all this if there's more than one condition. Otherwise, we simply set the conditions to data.weather0.main. So we don't even bother with that when there's only one condition, like here. Just one condition, 0, clouds, for whatever city that was. All right. So once we figure out our conditions, which go at the bottom here, we're then going to go ahead and create our actual output. So our output, which is all of this, starts with current conditions for, and I'm using string interpolation here. So data.name refers back to the data. There's the name, Miami. So we get current conditions for Miami. Now, by the way, these tick marks here let me use string interpolation and also multi-line strings. So you notice there's no syntax between these lines. I'm simply creating out as a giant long string. This was also added in JavaScript ES6. It's a great convenience if you work a lot with long strings like I'm doing here to create all the output for this particular application. So then we've got the temperature. And the temperature gets complicated. Look at this. All this is displaying the temperature. So we're using string interpolation. Let's start here. We're getting data.main.temp. So data dot main dot temp is giving us 297.81, which is in Kelvin. So first thing we're doing is we're sending that 287.81 data.main.temp to Kelvin to Fahrenheit. That's this function right here on line 19. It takes a temperature, it converts that temperature from Kelvin to Fahrenheit. That's the formula to do so. I didn't have that memorized, I had to look it up. And then returns the Fahrenheit temperature. So once we've run Kelvin to Fahrenheit, that's going to be a Fahrenheit temperature, and then I'm simply going to use math.round to round that to the nearest whole number. We don't need a temperature of 76.5753. We rounded it off. So math.round takes care of that for me. So again, we get this value from the data, from the weather service. That's in Kelvin, so we use my Kelvin to Fahrenheit function to convert it. We then round it off, and using string interpolation, we insert the value. Data.main humidity, that's the next one. We get the humidity, so that's right there, 88%, you can see. Adding the percent sign right there. Similar data.main.pressure, 1,013 millibars. You can see that right there in the data. I'm adding the MB right here. We're using the string interpolation, $, data.main.pressure in the curly brackets. And then the winds. So the winds come from the wind entry here. And we've got the degrees, the speeds, and the gusts. I just use the degrees and the speed. Now, of course, this particular weather service gives us meters per second. So in the US, at least, we don't talk about winds in terms of meters per second. We talk in terms of miles per hour. So we have to do another conversion. So here we go. So our wind, which is output as 230 degrees at some very specific miles per hour. So we're going to run the ms to mph, and we're going to feed it the wind speed. And actually, I'm going to take this math.round out of here. I have a better idea. That shouldn't make a difference at this point. But let's see here. We've got our ms to mph that's getting data.wind.speed, right? Data.wind, close that. Data.wind.speed 6.7. Sending that to ms to mph and converting it from meters to second to miles per hour, which just means you multiply it by 2.237. So that's going to display it right there. We're going to add the mph. Let's try a different city here. Let's try New Orleans. Hope I spelled that right. There we go. So their wind is 360 at 13.422 miles per hour. That 0.422 is bothering me a little bit. So let's wrap this whole thing here in math.round, because where it was before wasn't doing anything for us. And let's see if that's sufficient to give us a nice round number for our math. So first, we'll convert it using the converter from meters per second to miles per hour, and then we'll round it off. So let's try it one more time. New Orleans. And now we're getting a nice even 14 miles per hour. Last thing we're adding is the condition statement, which was generated up here, right? You remember all that, choosing whether or not there's an and looking at the array and seeing how many members there were. So that gives us 360 degrees at 14 miles per hour. So there you have it. You have a weather conditions app using the Onsen display API, or the Onsen JavaScript API that gives us this nice mobile appearance, and also the open weather map data. So in order to run this yourself, you're going to need to get your own key from the Open Weather Map API. It's easy to do. Once you have your key, you can run this, and I'd highly suggest you use this as a starting point and make modifications. Look at the other APIs that are available to you through Open Weather Map. Maybe you can do a forecast. Maybe you can add graphic displays. But this is designed to be a starting point that you can learn from. Thank you so much for watching. My name is Mark Lassoff from Framework Television. If you like this video, don't forget to like and subscribe to our channel. I'll see you soon.